This will be for the Khan Academy exercise, expand binomials. So they want us to expand this expression using the binomial theorem. And for your convenience, Pascal's triangle is posted with the first few rows. I'll show you that. Anyhow, the reason this is called a binomial is just because there are two terms. Anyhow, this is called Pascal's triangle. Okay, it's pretty easy to assemble. They did the first few rows. And what happens is all the rows on the outside are going to be 1. Okay, so this is 1 right here. This is 1 right here. This is 1 right here, and so on. Same thing on the right hand side. This is 1. This is 1. This is 1. Okay, and all you have to do is take the two numbers above and add them together. All right, so they started with a 1, and then the next row is 2 1s, and then right here to get 2, they added 1 and 1 to get 2. All right, right here you add 1 and 2 to get 3, and right here you add 2 and 1 to get 3. Right here you add 1 and 3 to get 4. Right here you add 3 and 3 to get 6. Right here you add 3 and 1 to get 4, and so on. Okay, so this is row 2. This would be row 3. This would be row 4, and so on. All right, so just remember, for the binomial theorem, try to remember that the row number is going to equal the exponent. Okay, so since our binomial was to the 4th power, we're going to be using this row right here. Okay, and the numbers in this row are going to be the coefficients when we expand the binomial. So I'm going to have to erase this, but let's record at the top. It's going to be, let me see here. It's going to be 1 4 6 4 1. Let me just write that on the top. 1 4 6 4 1. Okay, that's going to be our coefficients, as you will see. So I'm going to start by writing this out. See, we have 5 terms here. Okay, so we're going to be adding 5 terms to expand this expression. All right, and in each case, we're going to be multiplying r times negative 3t. So I'm going to start with that. All right, and each one, it's going to be r times negative 3t. And I'm going to leave a space in front of each one. Okay, a blank space, and you'll see why in a minute. So r times negative 3t. Okay, so I wrote r times negative 3 5 times with a blank space for each one. All right, so the blank space is going to be for the coefficients right here. Remember, this is to the 4th power. That's why we used row 4 on Pascal's triangle. So the coefficients are going to be 1 4 6 4 1. So this is 1 4 6 4 1. Okay, now the only thing left we have to do, other than simplify, is to take care of the exponents on each of these terms. Okay, so since this is to the 4th power, I'm going to start with the 4th power on r, and then the 0 power on negative 3t. Okay, the exponents always have to add to 4 each time. So the exponents on the r are just going to count down. We started with 4, then on this one it's going to be 3, then on this one it's going to be 2, then on this one it's going to be 1, then on this one it's going to be 0. Okay, and now we do the opposite with a negative 3t. We're going to count up. This one is to the 0, this one is to the 1, this one is to the 2, this one is to the 3, this one is to the 4. Notice in each case, the exponents add to 4. 2 plus 2 is 4, 1 plus 3 is 4, and so on. Okay, and now all we have to do is simplify this. So we know that anything to the 0 power is just going to be 1, and anything times 1 is just that term. So we can cancel out the ones that are to the 0 power. Okay, so the first term is 1 times r to the 4th. The second term is a negative. Okay, and we have negative 3 times 4, so that's going to be negative 12. R to the 3rd. And 3t to the 1st power. But we already did negative 3 times 4. Negative 3 times 4, that's negative 12. R to the 3rd, t to the 1st. Okay. Now over here, negative 3t squared. Negative 3 squared is positive 9, and t squared. So we have positive 6 times positive 9, that's positive 54. And we have r squared and t squared. All right, next up, negative 3 to the 3rd is negative 27, and the t is to the 3rd power. Okay, so we have 4 times negative 27. That's going to be negative 108. R to the 1st, t to the 3rd. And then finally, the last term is negative 3t to the 4th. Negative 3 to the 4th is 81. And that's going to be t to the 4th power. Remember, for the exponent, it's applied to each term. Okay, so that's 81t to the 4th. All right, and that is our final answer. All right, so we're going to have to enter this whole thing in the box here. We have r to the 4th. All right, for the exponent, you can click this or just type shift and the 6 key. Okay, so that's r to the 4th, hit the right arrow key, minus 12 r to the 3rd, hit the right arrow key, type t, plus 54 r squared, hit the right arrow key, t squared, minus 108 rt to the 3rd, and then finally plus 81 t to the 4th. Okay, so I typed that whole thing in the box. Just double check it real quick, make sure it matches. All right, one more. We want to expand this expression here using the binomial theorem. So we have our two terms, that's why it's a binomial, and the exponent is a 3. So when we get to Pascal's triangle, we're going to use row 3 for the coefficients. All right, here's Pascal's triangle. They filled in the first 3 rows. So we're going to fill in row 3. Okay, remember along the diagonals it's just a 1, and over here as well it's just a 1, In this box here, it's going to be 1 plus 2. And this box here, it's going to be 2 plus 1. Okay, so the row matches the exponent. Since we're in row 3, we're going to use these as the coefficients. So I'm going to write down up top 1, 3, 3, 1. Okay, those are going to be the coefficients. Okay, just like last time, we're going to write out the product of each of these terms. Okay, and make sure you maintain the plus minus sign, but in this case, they're both positive. So let's see. We're going to leave a blank space like last time. We have 3p times 4q. And we're going to add each time. 3p times 4q. And leave a blank space each time. 3p times 4q. Okay, and one more. 3p 4q. Okay, so I wrote it out 4 times because I have the 4 coefficients here. So let's put the coefficients in the blank spaces. We have 1, then 3, then 3, and then 1. Okay, and we're going to do our exponents. So the exponent here is 3. So we start with an exponent of 3 right here. And this is a 0 right here. Remember, the exponents have to add to 3. Now on the 3p, I'm just going to count down for the exponents. This is 3, 2, 1, 0. Okay, and on the exponent for 4q, I'm just going to count up. This is 0, 1, 2, 3. Okay, now anything to the power of 0 is just 1, so we can cancel that, and we can cancel that right there. Okay, so this is 1 times 3p to the third. 3 to the third is 27, and p is to the third. Okay, here we have 3p squared. 3 squared is 9. And p squared is p squared. Okay, so the coefficient is 3 times 9 times 4. That's going to be 27 times 4, and that's positive 108. P is squared, and q is to the first. Okay, over here we have 4q squared. 4 squared is 16. Okay, 3 times 3 times 16. It's going to be 9 times 16. 90 plus 54 is 144. P is to the first. And q is squared. And then finally, this is 1 times 4q to the third. 4 to the third is 64, and we have q to the third. So that's the answer. Okay, so we're going to enter this whole thing in the box. Remember, you can use this symbol right here for the exponent, or you can use the caret symbol on your keyboard. So we have 27p to the third. Hit the right arrow key, plus 108 p squared times q, plus 144 pq squared. Hit the right arrow key, plus 64q to the third. Okay, double check and make sure it matches. And it looks good.